Hi, welcome to a lecture on engineering mechanics. I am Dr. S. Satish, Assistant Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchendur. Today we are going to discuss a topic, resultant force. Resultant force. It is possible to replace the number of forces acting on a particle by a single force which could produce the same effect as that of the original force, which will be called it as a resultant force. Let me consider a particle or a body in which a number of forces will be acting on it. So these number of forces will be expressed or defined in terms of resolved in terms of a single force which will induce a same effect as that of these number of forces. That single force which will be expressed equivalent to these number of forces is being called it as a resultant force. If two forces are acting on a body, then it will be resolved with the help of parallelogram law of forces. If more than two forces are acting on a body, then it can be resolved with the help of resolution of forces. Now let me take an example. So see here, so the forces 2 Newton is acting on the right hand side, then another force of 4 Newton which will be acting in the right hand side direction, then another force of 3 Newton and 2 Newton are acting on the right hand side of this. So these forces can be expressed or resolved into a single force which will induces a similar effect of that force. So let me take, so these forces, summation of these forces, which is nothing but 2 Newton plus 4 Newton plus 3 Newton plus 2 Newton, which will induce us a force of 11 Newton in the direction of right hand side. So this can be expressed as a single force as shown here. So 11 Newton of force is been acting, that will be the magnitude, and the direction of force which will be positive, hence the direction of force will be right hand side. So you can observe here, so 11 Newton force is been acting on the right hand side direction. Let me take another example. You can see here, so similar thing, 2 Newton of force which will be acts in the right hand side direction, then 4 Newton of force is been acting along the left hand side direction, and another 3 Newton and 2 Newton are acting in the right hand side direction. Now if you find what is the resultant force, so 2 Newton which will be right hand side, so another 4 Newton which is left hand side, so negative symbol of for 4 Newton force, other 3 and 2 will be added here. So you can get the resultant force of 3 Newton. So this can be expressed in this way. So this magnitude of 3 Newton force which will be acting in the direction of right hand side, since it is the positive 3 Newton, hence it will be acting on the right hand side direction. So this is how the total number of forces which will be acting on a particular particle or a body can be expressed in a single force. So that will be called it as a resultant force. So now let me discuss about the parallelogram law of force. So first we'll have a look on the law of parallelogram. So if what it says, if two forces are acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram, the resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. So this is the parallelogram law of force. So let me see an example. Let me see. Consider this as a particle. So this point will be positioned as O. So now a force of P is acting in the right hand side. Another force of Q will be acting on this same particle. So these two forces are inclined at an angle of theta. So look at here. This is a particle. So in this particle, a force of P is being acting and force of Q is acting on this particle. So both these force will be inclined, will have an inclination angle of theta. So now, as per this law of force, so these the resultant force of these two forces which will be acting on this particle can be expressed in terms of a single force which will be called as a resultant force, which will be the diagonal of this parallelogram. Let me constitute a parallelogram. So just consider a line of force which will be equivalent to P. So in the direction which will be parallel to this force P, and again draw a line which will be equal in magnitude of Q and parallel to this Q. So now we can able to observe this parallelogram. So we can name it as ABC, OABC as a parallelogram, and the diagonal will be the OC. So the resultant force of these two forces P and Q will be expressed in the diagonal of this force parallelogram. Okay. So the magnitude can be observed here, identified. Then the angle of inclination of this resultant force will be expressed in alpha. So how we will find how the magnitude will be calculated, and the angle of inclination of these resultant force will be calculated. So now we will draw a vertical line CD, and now we will extend the line OA till D. So now we can able to observe, we can get a triangle of ACD. So consider this triangle ACD, and this will be inclined as theta. So this P will be inclined at an angle of theta with respect to this OA. Hence this will be, the angle will be theta. So with this triangle, we can able to identify the CA, AD and CD. So based on this trigonometric relationship, sin theta is equal to CD by Q. Okay. So from this we can able to observe this CD is equal to Q sin theta. And meanwhile, we can able to observe cos theta is equal to AD by Q. So from this we can find AD is equal to Q cos theta. So we know that this AC square is equal to AD square plus CD square. So with this AD and CD, that is the value of Q sin theta and Q cos theta, if you substitute here, we can able to identify what is the value of AC. So which is nothing but Q square sin square theta plus Q square cos square theta. If you simplify this, we will get AC is equal to Q square. Okay. So now let me take the triangle OCD. Okay, this triangle which will be represented here. So you can able to observe here OD is nothing but OA plus AD. So this AD is been represented in green color. So now we can find that this OC square, which is equal to OD square plus CD square. So this OD square can be expressed as OA plus AD as written here. So OA plus AD whole square plus CD square. See, this OA plus AD square can be written as A square plus B whole square. So with this formula, A square plus B square plus 2AB. So hence OA square plus AD square plus 2OA AD. So this CD square. So from the previous equation, we can able to observe that AD square plus CD square. Okay. So we know that. So hence we have been written as OA square plus 2OA plus AD and AD square plus CD square. So this AD square plus CD square is nothing but your AC square, as we have been identified in the previous slide. So now this OC square is equal to OA square plus AC square plus 2OAAD. Okay. So now this OA is nothing but the force P. So we can express as P square, and AC. So AC is nothing but the parallel and equivalent to force Q. Hence it will be represented as Q square. So plus 2 into OA is P and AD is Q cos theta, which will be observed earlier. So this can be written as, so this is resultant force R is equal to square root of P square plus Q square plus 2P Q cos theta. So the resultant of these two force P and Q, which will be acting on a particle, can be identified with this relationship. R is equal to square root of P square plus Q square plus 2PQ cos theta. So now the angle of inclination of these resultant force alpha can be observed with this relationship, that is tan alpha, which is equal to CD divided by OD. So we have find that CD is equal to Q sin theta in previously, and OD equal to OA plus AD. So this OA is nothing but P and AD is nothing but Q cos theta. So this can be expressed as Q sin theta divided by P plus Q cos theta. So therefore the angle of inclination of this resultant force alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta. So this is how the resultant force and the angle of inclination of this resultant force, which will be equivalent to the force P and Q, which will be acting on this particle, can be identified. So next class we will discuss about the resolution of force. Thank you.